In this video here, we're going to start taking a look at properties of triangles. And while some of this is going to be review from, actually most of this is going to be review from grade 10 math, but it's important that we take a look at the basis of it, as well as some of the things that we're going to talk about notation-wise, which is what we're going to look at right off the bat. So let's take a look at just some agreements that we're going to deal with, and we're going to say that these are what we're going to call facts. Now, capital letters are often used to label the vertices of a triangle. The same lowercase letter is used to label the side that is opposite of the vertex. Okay? So what that means here is if we have this triangle right here, okay, what we're going to do is we're going to call this triangle ABC. So we're going to title this vertex is going to be A, this one is going to be B, and this one here is going to be C. Now, this triangle here, you'll notice is triangle ABC because it goes from A to B to C. It involves those 3 points, and that's the triangle it's made. This triangle right here, I'm going to use a different set. I'm going to call this X, Y, and Z. So I'm using just 3 different letters, but again, it's fine. We can use different letters. We don't have to necessarily use the exact same letters all the time. So with this triangle right here, okay, now the side that is opposite of the vertice is going to have the same letter except lowercase. So the one that is opposite A, so that would be this one right here, is going to have the term little a. So we're going to call this one little a. That side is equal to little a. Now we could also call it line segment BC, okay, and normally we would put a line over top there. Make sure to, there we go, it's line segment BC. So it's a line segment from B to C. So it goes across there. Now across from B, we're going to have side B, which is also equal to line segment AC. And let's get that little line over top. That little line represents a line segment. And so this could be line segment AC. It could also be represented as side B. Now, if we're just dealing with a triangle, we might as well just call it side B. But if we're dealing with something a lot bigger than a triangle, like we did back in when we were looking at parallel lines and triangles, then we might want to consider this to be a line segment between A and C. And finally, across from C, okay, so again, these are the ones that do not touch that specific vertice. This is line segment C or AB. And again, we're going to put our little line over top there. Okay, so that represents AB. So we have A, B, and C represent our 3 sides, and we could also represent them with the dual letters as well. Now on this side here, I'm not going to do the line segment, I'm just going to do the little letters. So this one's going to be Y because it's across from Y. This one is going to be Z because it's away from Z. And this one's going to be little x because it is away from or not touching the x value right there. So this is how we're going to label a triangle, and we're going to make sure that we recognize that there are a couple different ways to represent a side length, but we're going to try to use the little letters for the most part. Every once in a while, we're going to dive into these line segments as well. Now, you should be familiar with the 3 trigonometric ratios of an acute angle from grade 10 math. So you should be familiar with them. Those are sine, cos, and tan. Now, to do sine, cos, and tan, we need to look at triangles and see specifically certain sides. So the first thing is we want to see what is our hypotenuse. Now, remember that this is our longest side. Okay. It is also across or not touching, if you think of it that way, the right angle. Okay, so it's across, it's not touching the right angle. It's going to be this side right here. Okay, again, it's not touching. It says it's wrong. I'm going to add that to my dictionary because I like height. Okay, it's across from our right angle. Okay, it's the longest side. In this triangle here, it's going to be this bottom piece right here, okay, as it's not touching our right angle. So that's our hypotenuse. It's the longest side. It's the one that's not touching the right angle. Now, the other 2 sides that we have, one is the opposite, and this is the opposite side of and I'm going to call it the desired angle. And again, this is not touching the desired angle. Okay, and when I say desired angle, we have to remember that we will always have some angle in our triangle, and we'll often call this angle theta. And that's a really bad theta there, but that works. I'm going to call this one theta right here. Okay, this is our desired angle. We might know what the angle measurement is on this one. We might not know what the angle measurement is on this one. We might be trying to find it. We might actually be given the angle measure. Now, the opposite side is the one that is not touching this here. So this leg right here, and I should actually change that to leg, the opposite leg of the desired angle. So the opposite leg would be this one right here. Okay, so this one here is not touching the desired angle. So this is going to be our opposite side, and I'm gonna just go OPP in there, and then here we have two legs. We have this leg and this leg here. This one here is not touching the desired angle, so this one is going to be our opposite side as well. Finally, we have the adjacent side. So the adjacent side is the leg that is, that is touching the desired angle, or you might want to say attached to the desired angle. Okay, it's the one that is right beside. So in this case here, it's our last leg. I'm going to call it ADJ. And on this side here, I'm also going to do the same thing. ADJ, it's the one that is touching our desired angle. Now, being able to label is super important. Making sure that we know which side is which is extremely important, because we want to make sure that we recognize our, again, that notation. That notation is super important when it comes to doing our trig ratios. Three ratios that we have sine theta is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. All of these are going to be able to give us an opportunity to solve for a trig ratio, or sorry, solve for a side or an angle. Now, some of you might have gone through the use some of these notations here. This is koa, Sokotoa. There we go. Sorry. Okay, we have our little notation, Sokotoa. You can think of it that way as well, if that's a little bit of a way of remembering that. You can also put this on a cheat sheet if you want to as well, to remember what our three ratios are. Today's lesson, like I mentioned, is going to be review. It's just going to be going over those three ratios right there. Now, last thing I want to go through in this video before I'll stop and get into our next video, is just a few things to look at when we are using SOHCAHTOA. What are some things to be aware of when we're using SOHCAHTOA? So the first thing that we want to make sure of is we want to make sure the triangle has a right angle in it. Okay, and remember that right angle is a 90-degree angle. Okay. So that's one thing that we want to make sure of. We want to make sure that it has a right angle. Okay, that's super important. If it doesn't have a right angle, these ratios mean absolutely nothing. Okay, it has to have a right angle in it. The second thing that we want to make sure we do is that we never choose the 90-degree angle or the right angle as our given angle. Okay. That will always be theta. So if we look back here, theta will always be given as one of our other two angles. It will not be our right angle. Okay, so we never use that as our given angle. We always use either whichever one theta is in, or whichever angle that is that we have a value for. Next thing is we want to identify and label the three sides. So this is our opposite, our adjacent, and our hypotenuse. Make sure that those are labeled, and try to do that with correct spelling there as well. It's always good. Good thing I'm doing it on the computer here, so I'm able to correct my values here. And the last thing that we want to make sure we want to do is we're going to choose two sides to complete a trig ratio. Okay, we're going to pick two of them, whichever two are either given, or the one that is given and the one that we are trying to find. The third side we really do not need to worry about at this point, because that's going to be used later on. For right now, we're just looking at those two sides that we are either given or the one side we're given and the one side that we're trying to find. And there's the buzzer. It's time to end the video.